Welcome, architects and senior developers. Today we are moving beyond generic, off-the-shelf AI agents. We will master how to design and build proprietary reasoning loops from scratch. Let's get started. Let's define what we mean by a proprietary reasoning loop. While off-the-shelf agents like a standard React implementation are great for basic tasks, they often act as black boxes. When you hit production-level complexity, these generic agents fail because they lack domain-specific cognitive structures. Building a proprietary loop from scratch means moving away from prepackaged agents and manually designing the state machine. You dictate exactly how the LLM plans, when it is allowed to act, and how it must reflect on its errors. This gives you ultimate control over the agent's thought process, ensuring it adheres strictly to your unique enterprise workflows and compliance constraints. Take a look at this comparison on the screen. On the top, the standard agent feeds into a black box where the reasoning is hidden. On the bottom, our proprietary loop exposes the cognitive steps. We explicitly wire a custom plan node, followed by a domain verification node, and finally a tool execution node. You control the exact sequence of thoughts. The absolute foundation of a custom reasoning loop is explicit state management. In a proprietary loop, you must define the exact data structure that flows between your steps. Using Python's typedict or pydantic, you define a state object. This state doesn't just hold the chat history, it holds your custom cognitive variables. For instance, you can track the current plan, log validation errors, or maintain an iteration count to prevent infinite loops. As this state object moves from node to node, each function reads the context it needs and returns specific updates. This explicit, transparent state is what allows you to build highly complex, auditable reasoning paths. This diagram visualizes our explicit state structure. The initial user request enters the graph state, which is broken down into precise channels, messages, a current plan, and an error count. Node 1 reads from these channels, performs its cognitive step, and returns updates directly back into the state, ready for the next node to process. Once our state is defined, we build the cognitive engine using nodes. Nodes are just Python functions that act as the distinct brain regions or hands of your agent. The secret to proprietary loops is decoupling reasoning. Instead of asking one LLM call to do everything, you create a node exclusively for planning, another exclusively for executing tools, and a third for critiquing the output. This is where advanced architectural tricks come in. For example, if your critique node finds a flaw, you can cast its feedback as a human message before passing it back to the planner. This subterfuge trick bypasses the LLM's dialogue tuning limits, forcing it to treat the critique as a strict user command. Here we see the decoupling of cognition. The state feeds into the planner node, which updates the current plan. This plan flows to the critique node. If the critique fails, the feedback is cast as a human message and looped back. If it succeeds, the flow progresses to the execution node. This separation of concerns is what makes custom loops so powerful. To make these nodes function as a loop, we must wire them together using conditional edges. This is your dynamic routing layer. A conditional edge is a function that inspects the current state and mathematically decides where the workflow should go next. Building a loop from scratch introduces the risk of infinite loops your agent might critique and refine endlessly, draining your API budget. Conditional edges solve this. Your router function can check the error count in the state. If it exceeds 3, it routes to the YND node, returning the best draft. This is also exactly where you inject fail-fast compliance checks or pause the execution to ask for human approval. Look at the router function at the center of this diagram. It acts as the traffic controller. Based on the output of the critique node, it checks the state. If the plan is valid, it routes to the final answer. If the error count is too high, it routes to a fallback. Otherwise, it loops the execution back to the planner node for another attempt. Let's look at the actual code implementation using LangGraph. The syntax is remarkably clean for how much power it provides. You start by instantiating the state machine with stategraph, passing in the custom state schema we defined earlier. Next, you use a node to register your Python functions, giving each a string identifier like planner or executor. Then, you wire the logic using add-edge for static paths and add conditional edges for your dynamic routing functions. The final, critical step is calling the compile method. This validates your graph structure and locks the architecture into an executable application. To run it, you simply call invoke, passing in the initial user request, and the framework takes over the heavy lifting. This class diagram demystifies the LangGraph API. The stateGraph class exposes the methods you need, add node, add edge, and add conditional edges. Once your configuration is complete, the compile method generates the compiled graph object, which exposes the invoke and stream methods used at runtime in your application. Let's apply this to a high-stakes, real-time use case, enterprise loan processing. If you use a generic agent here, it might hallucinate an approval based on missing data, causing massive financial loss. Instead, we build a custom fractal chain of thought, or FCOT loop. Node 1 is forced to lay out a strict plan. Node 2 executes tools to fetch the exact credit score. Crucially, Node 3 is a dedicated verification node. It takes the output and rigorously evaluates it against banking compliance regulations. If the risk score is too high, the routing logic bypasses the approval node entirely and forces a formal rejection with an auditable explanation. By controlling the loop, we eliminate hallucinated approvals. Follow the FCOT loan processing flow. The request hits the planner, then the tool execution node. The critical safety net is the compliance verify node in orange. Because we built a proprietary loop, we mathematically guarantee that no request can reach the approval node without first passing this strict compliance evaluation. As we conclude, keep these architectural best practices in mind. Always start simple. Build a 2-node graph before a 10-node graph. Be extremely vigilant about state bloat. If you append every single internal thought to the state's message list, you will quickly blow up your LLM's context window. Build a dedicated node just to summarize or trim older messages. Finally, implement robust error handling. If a tool fails, don't crash the graph. Catch the error and pass the error string back into the loop so the LLM can attempt to self-correct. Mastering proprietary reasoning loops is what separates amateur chatbot wrappers from true enterprise-grade AI architecture. Thank you for joining this masterclass. I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final mind map summarizes your path to mastery. From your custom reasoning loop, you must branch out into starting simple, monitoring state bloat via trimming nodes, and implementing retries to unlock LLM self-correction. Follow these principles, and your agentic architectures will be unstoppable.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.